Welcome to the chapter on circuit analysis. Understanding and predicting the behavior of electrical circuits is fundamental in electrical engineering. In this chapter, we will explore series and parallel circuits, Kirchhoff's laws, Kirchhoff's law for nodes, and Kirchhoff's law for meshes. In a series circuit, components are connected end to end, creating a single path for current to flow. The current remains the same through all components, but the voltage across each component can vary. The total resistance in a series circuit is the sum of the individual resistances, given by the formula R total equals R1 plus R2 plus R3, and so on. The total voltage is the sum of the voltages across each component, given by V total equals V1 plus V2 plus V3, and so on. The current remains the same through all components, represented by I total equals I1 equals I2 equals I3, and so on. Consider a series circuit with three resistors. R1 equals 2 ohms, R2 equals 3 ohms, and R3 equals 5 ohms. If the total voltage supplied is 10 volts, the total resistance is 10 ohms. The current through the circuit is calculated as I equals V total divided by R total, which equals 10 volts divided by 10 ohms, resulting in 1 ampere. In a parallel circuit, components are connected across the same 2 points, providing multiple paths for current to flow. The voltage across each component is the same, but the current can vary. The total resistance in a parallel circuit is given by the reciprocal of the sum of the reciprocals of the individual resistances, represented by 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3, and so on. The total current is the sum of the currents through each component, given by I total equals I1 plus I2 plus I3, and so on. The voltage remains the same across all components, represented by V total equals V1 equals V2 equals V3, and so on. Consider a parallel circuit with three resistors. R1 equals 2 ohms, R2 equals 3 ohms, and R3 equals 6 ohms. If the total voltage supplied is 12 volts, the total resistance is calculated as 1 over R total equals 1 over 2 ohms plus 1 over 3 ohms plus 1 over 6 ohms, which equals 1 ohm. The total current through the circuit is I total equals V total divided by R total, which equals 12 volts divided by 1 ohm, resulting in 12 amperes. Kirchhoff's laws are fundamental in circuit analysis, providing rules for the conservation of charge and energy in electrical circuits. Kirchhoff's current law states that the total current entering a junction, or node, must equal the total current leaving the junction. This law is a consequence of the conservation of electric charge. The mathematical formulation of Kirchhoff's current law is represented by the sum of the currents entering a node equals the sum of the currents leaving the node. Consider a node with three branches, where I1 and I2 are currents entering the node, and I3 is the current leaving the node. According to Kirchhoff's current law, I1 plus I2 equals I3. Kirchhoff's voltage law states that the sum of the electrical potential differences, or voltage, around any closed loop or mesh in a circuit is 0. This law is a consequence of the conservation of energy. The mathematical formulation of Kirchhoff's voltage law is represented by the sum of the voltages around a closed loop equals 0. Consider a closed loop with three components having voltages V1, V2, and V3. According to Kirchhoff's voltage law, V1 plus V2 plus V3 equals 0. Kirchhoff's current law can be applied to analyze the current at any node in a circuit. This law helps in determining unknown currents in complex circuits. In a circuit with a node where four branches meet, with currents I1, I2, I3, and I4, if I1 and I2 are entering the node and I3 and I4 are leaving the node, then according to Kirchhoff's current law, I1 plus I2 equals I3 plus I4. Kirchhoff's voltage law can be applied to analyze the voltage in any closed loop or mesh in a circuit. This law helps in determining unknown voltages in complex circuits. In a circuit with a closed loop containing three resistors with voltages V1, V2, and V3, and a voltage source Vs, according to Kirchhoff's voltage law, Vs minus V1 minus V2 minus V3 equals 0. By rearranging, We get Vs equals V1 plus V2 plus V3. This chapter provides a foundational understanding of circuit analysis, essential for any electrical engineering student. By mastering these concepts, students will be well equipped to tackle more complex circuits and systems in their future studies.